Good day everyone, I'm your Mr. ATL and welcome back to my channel. So today's video, I'm going to give you sample problems involving inverse trigonometric functions. So let's start. Okay, so the first step that we're going to do is to let this expression be equal to theta. So let theta be equal to inverse sine of negative 1/2. Okay, if theta is equal to sine inverse of negative 1/2, we can say that sine theta is equal to negative 1/2. But we are looking for the value of theta. So to do that, you're going to think of a value of theta where the range is from negative pi over 2, pi over 2. Which corresponds to the sine value. Okay, so if you already memorize your unit circle, you can find out that your theta is equal to negative pi over 6. Or if not, you may look for your unit circle. So from the range negative pi over 2 until pi over 2, you can find out that negative 1/2 can be found in here, and that is the y-coordinate or the sine value of the negative pi over 6. Okay, so therefore the answer here is negative pi over 6. Using our calculator, you may compute for the value of inverse sine of negative 1/2. And how is that? So this is your calculator. You are going to press the shift button. So shift, then sine, that is inverse sine of negative 1/2. So we need negative, then 1/2. So 1 over 2 and then close. So it will give you negative 30 degrees. So negative 30 degrees is also equal to negative pi over 6. Okay, let's proceed to the next example, number 2. Okay, example number 2, we have inverse cosine of negative square root of 2 over 2. So again, we may let theta be equal to inverse cosine of negative square root of 2 over 2. So in this particular equation, this is also equivalent to cosine theta equals to negative square root of 2 over 2. Okay, but we are referring to the value of theta. So to do that, you're going to think of the value of theta in which the range is from, okay, you are going to find the value of theta which is negative square root of 2 over 2 from 0 to pi. Okay, so in inverse cosine, the range is from 0 to pi. So meaning to say, you're going to look for the value of theta in the range 0 to pi that corresponds to the value of cosine, that is negative square root of 2 over 2. So looking in our unit circle, you can see that from 0 to pi, you can find that negative square root of 2 over 2 is in here, and that is your 3 pi over 4. So the answer here is 3 pi over 4. Okay. Okay, example number 3, we have inverse tangent of negative square root of 3. So again, let us let this expression be equal to theta. So theta is equal to inverse tangent of negative square root of 3. So with that, we can say that this is tangent theta equals to negative square root of 3. So again, you're going to think of the value of theta from, let us look at the range of that inverse tangent. So this is the domain, this is the range. So from negative pi over 2 until pi over 2. So let's get our unit circle. So we will just look for negative pi over 2 until pi over 2 only. where you will get the tangent value of negative square root of 3. Okay? But we do not have the exact negative square root of 3. But instead, we have square root of 3 over 2. We have 1 over 2. And we also have square root of 2 over 2. But manipulating this to get negative square root of 3, we may need to divide the square root of 3 over 2 by 1/2. And dividing this, it will give you square root of 3 over 2 times the reciprocal of that, which is 2 over 1 or 2. Then simplifying this, it will give you square root of 3. But we need negative square root of 3. So one of these will be negative. So looking at your unit circle, since this is a tangent value, okay, so this will be your y and this will be your x. So looking at your unit circle, we can see that we have here square root of 3 over 2 and 1/2, but your x here is square root of 3 over 2, but it should be your y. Looking at this point, we have your y is negative square root of 3 over 2 and your y is 1/2, and this will give you square root of 3 or negative square root of 3 for if your y is negative. So we will have negative square root of 3. So what is that? From negative pi over 2 until pi over 2 only. So therefore that is negative 60 degrees or negative pi over 3. So therefore we can say that the value of the inverse tangent of negative square root of 3 is negative pi over 3 or negative 60 degrees. So using our calculator, we can also find that the inverse tangent of the negative square root of 3 will give us negative 60 degrees, or in radian that is negative pi over 3. Okay? Example number 4, we have inverse cosecant of square root of 2. So again, let theta be equal to the cosecant inverse or inverse cosecant of square root of 2. So this is equivalent to cosecant theta equals to square root of 2. But we are trying to find out the value of theta. So you're going to think of the value of theta in the range from, so let us look at the table in here. So our cosecant, our inverse cosecant theta is in here. So this is the domain and this is the range. So we will just look at the interval of from where? From 0 to, from negative pi over 2 to 0 excluding 0, and from 0 to pi over 2 excluding that 0. Okay? So we will find the value of square root of 2 as the value of the cosecant function. But cosecant function is 1 over y. Okay? So 1 over y is also 1 over sine. So looking at our unit circle, we can find out, we will just look, or we will just give our focus on the y coordinate. So this is negative, so we cannot find this, we cannot use this. On the other quadrant, we have the square root of 2 over 2, which is the pi over 4. So if your sine pi over 4 is equivalent to square root of 2 over 2, therefore your cosecant pi over 4 is the reciprocal of this, and the reciprocal of that is 2 over square root of 2. Rationalizing the denominator by multiplying by square root of 2 over square root of 2, this will give us 2 square root of 2 over square root of 4, which is 2. Simplifying this, that is square root of 2. Okay, we found it. So therefore, the value of theta is pi over 4. And also, the value of inverse cosecant of square root of 2 is pi over 4. Okay, so let us use our calculator in finding the value of the inverse cosecant of square root of 2. So, inverse cosecant, let's say x. Inverse cosecant x is also the same with so remember that inverse cosecant x is not equal to 1 over inverse sine of x. So always remember this, they are not equal. So our purpose is to use calculator in computing for inverse cosecant of square root of 2. So let us find first, or let us have an illustration first. Suppose we have here an angle theta. So to find the sine theta, let's say we have here this is your y, this is your x, and this is your r. So to find the sine theta, we will have sine theta equals to the opposite side, which is y, over the hypotenuse r. So if we have cosecant theta, that is the reciprocal of sine theta. So cosecant is the hypotenuse over the opposite side, so that is r over y. So look at the relationship of the values of the sine and cosine. They are the reciprocal of each other. Okay, so sine theta equals to y over r corresponds to the value of theta, which is the inverse sine of y over r. Also, this cosecant theta equals r over y corresponds to the value of theta, which is inverse cosecant of r over y. But then, looking at the angle, they are just equal. So we can say that inverse sine of y over r is equal to inverse cosecant of r over y. So look at this. You will just get the reciprocal of that for you to find it. So going back to our previous question, which is the inverse cosecant of square root of 2, we can say that this is equal to the inverse sine of 1 over square root of 2. Okay? So using our calculator, we will just input this inverse sine of the 1 over square root of 2. So let us try that. Okay, so our answer must be pi over 4, or in degree, that is 45 degrees. So we have inverse sine of 1 over the square root of 2. So we will get 45 degrees. So therefore, this is equivalent to pi over 4, or 45 degrees. Okay, another question, we have inverse secant of 2. So again, let this expression be equal to theta. So theta equals to inverse secant of 2. And also, this is equivalent to secant theta equals to 2. So looking at our table for secant, the domain here is this, and the range is from 0 to pi over 2, and from pi over 2 until pi, excluding the pi over 2. Because when you have the secant of pi over 2, what will be the answer? So this is the pi over 2, the secant of that is 1 over x, or 1 over 0, that is undefined. Okay, so again, we are going to find the value of theta in the range 0 to pi over 2, and then pi over 2 to pi, excluding pi over 2. That will give a secant value of 2. Okay, so in here, we have here from 0 to pi over 2, excluding the pi over 2, and from pi over 2 to pi, excluding pi over 2, we will find the secant value of 2. So secant value is 1 over x. As you can see, we do not have 2 there, but we have here 1/2. If we are going to get the reciprocal of 1/2, that will be equal to positive 2. So we are going to find or we can find it here. Okay, the reciprocal of 1/2 or 1/1/2 will be equals to 2. So we can also find it in here, but this is negative, so we will not use that. So we are going to use the value of pi over 3, which is 60 degrees. So therefore, the value of theta is pi over 3 or 60 degrees. Okay? So using our calculator, we will do the same thing with our previous example in cosecant. So inverse secant of 2 is equivalent to inverse cosine of 1/2. Okay, so using our calculator, what will be the answer? We have inverse cosine of 1/2. So the answer will be 60 degrees or pi over 3. So this is the answer. And let us have number 6. Okay, number 6. We have inverse cotangent of the square root of 3. So let theta be equals to inverse cotangent of square root of 3. So this corresponds to cotangent theta equals to square root of 3. Okay, so looking at the range of the cotangent function, of the inverse cotangent function, that is from 0 to pi, excluding 0 and pi. Because if it is 0, if it is pi, we will get an undefined answer. So again, using our unit circle from 0 to pi, excluding 0 and pi, so in here only. So we are going to find the value of the theta ranging from 0 to pi, excluding 0 to pi, that will give us a cotangent value of the square root of 3. So once again, we do not have square root of 3 coordinates there, but we need to manipulate them to find that x over y is the square root of 3, because cotangent is x coordinate over the, or divided by the y coordinate. Okay, so we can find it. If we will use this negative square root of 3 over 2 over 1/2, it will give us negative square root of 2. So we need a positive version of this. So okay, so we have here the pi over 6. So let us check. If your x coordinate is square root of 3 over 2 divided by your y coordinate, that is 1/2, will it give you square root of 3? So simplifying this, that is square root of 3 over 2 divided by the, or multiplied by the reciprocal of 1/2, which is 2 over 1 or 2. So simplifying this, it will give you square root of 3. So therefore, the value of theta is 30 degrees or pi over 6. Okay, so what are you going to do using calculator? So using calculator, this is equivalent to the inverse tangent of 1 over square root of 3. So let us check if this is true. So we have here our calculator, shift tangent, then we have a fraction there. It's 1 over square root of 3, then close. So that is 30 degrees. Okay. Okay, example number 7. What if the question is the combination of the two trigonometric functions? So we have here the cosine of the inverse sine of negative 1/2. So in this particular question, we must give our focus first on this part. So let us this term be equal to theta. So let theta be equal to inverse sine of negative 1/2. So if this is theta, it will become cosine theta. So the whole expression is now cosine theta, and that is the thing that we need to find its value. So to do that, going back to this is now equivalent to sine theta equals to negative 1/2. Okay, so you know that the range of this inverse sine function is from negative pi over 2 until pi over 2. So we're going to find the value of theta in which the sine value is negative 1/2. Okay, so again, from negative pi over 2 until pi over 2, the sine value of negative 1/2, which means our y coordinate will be negative 1/2. So where? Okay, so we can find it here, and that is your negative pi over 6. We will not use 11 pi over 6 since our range only is from negative pi over 2 until pi over 2. So we will be using the negative pi over 6. So the value of this inner term is pi over 6. So the value of this inner term is negative pi over 6. So let us use that. So we will have cosine of negative pi over 6. Okay, so it will become cosine of negative pi over 6, and the value of this, using your unit circle of, if you already memorized this, you can find out that the cosine of negative pi over 6 is the square root of 3 over 2, and that is the answer, square root of 3 over 2. Okay, so let us give alternative solution for this. Okay, I'll be separating these solutions. So this is the given, and we will find the value of this term. Okay, so from your theta equals to inverse sine of negative 1/2, it is the same with sine theta equals to negative 1/2. Okay, so if we are going to locate this on our Cartesian plane or on a unit circle, if we're going to draw this, we have here, we can find it in quadrant 4. Since the sign is negative. So again, it's from negative pi over 2 until pi over 2 only. So negative 1/2 means your opposite side has a measure of 1 unit and your hypotenuse is 2 units. So this is 2 and your opposite side is negative 1. Okay? So for us to find the cosine theta, we need to use, or we need to find the measure of the adjacent side divided by the measure of the hypotenuse side, or the hypotenuse. Okay, so we have only the value for the hypotenuse, which is 2, but we do not have value for the adjacent side. So to do that, by the Pythagorean theorem, we have here, this is your C, this is your, let's say, B or A, or that is your B. So in our Pythagorean theorem, we have C square equals to A square plus B square. The value of C is 2, then square of that is 4, equals to, A is missing. We have here A square, and our B is negative 1, square of that is positive 1. Solving for A, we will get A square equals to 4 minus 1. And that is A square equals to 4 minus 1 is 3. And we have here A, that is square root of 3. So your A now is square root of 3. So therefore, your adjacent side is square root of 3. And we will get the same answer of square root of 3 over 2. Okay? Another way of solving this is by the use of calculator. So using our calculator to find the cosine of the inverse sine of the negative 1/2. So we have cosine, then the inverse sine of the negative 1/2. So negative, then 1 over 2. Okay, so we will be using close parenthesis for to close the to close the negative 1/2 and to close the inverse sine, another parenthesis. So another parenthesis for that. So press equal sign, that is square root of 3 over 2. Next, another problem, number 8. Find the exact value of sine of 2 inverse sine of negative 3 over 5. Okay? So, let us use the inner function, the inner inverse function of inverse cosine of negative 3 over 5. And we will let theta be equals to that. So, theta is equal to inverse cosine of negative 3 over 5. This implies that your cosine theta is equal to negative 3 over 5. You may use the illustration of this cosine theta equals to negative 3 over 5, or you may also use the Pythagorean identity from cosine square theta, cosine square theta plus sine square theta is equal to 1. So our cosine theta is negative 3 over 5. Substituting it in here, we will get negative 3 over 5 square plus sine square theta equals 1. So the square of 3 over 5, that is 9 over 25 plus sine square theta equals 1. Solve for the sine theta, that is sine square theta equals to 1 minus 9 over 25. Then solving for this, sine square theta is now equal to 16 over 25. So this is over 1. The LCD is 25 divided by 1 is 25 times 1, 25. Minus 25 divided by 25 is 1 times 9 is 9. So 25 minus 9 is 16. So the value of the sine theta now is equal to the square root of 16 over 25, that is 4 over 5. Okay. So going back to the original expression, sine of 2 inverse cosine of negative 3 over 5, this is equivalent now to sine 2 theta, and that is what we are looking for. Since from the double angle identity of the sine function, sine 2 theta is equivalent to 2 sine theta cosine theta. Okay. We have the value for the cosine theta. We also have the value for the sine theta. So substituting it in here, we have 2 times your sine theta is 4 over 5. Multiplied by your cosine theta is negative 3 over 5. And then simplifying this is over 1. Multiplication of fractions, numerator to numerator. So 2 times 4 is 8 times negative 3 is negative 24. Over 1 times 5 is 25. So therefore, the value of the sine 2 theta is negative 24 over 25, and the value of this expression is negative 24 over 25. And this is our final answer. Okay? So, another method of finding the answer in here using your calculator, we may press the sine function times 2 and times the inverse cosine, shift cosine, times, there is a fraction. We have negative 3 over 5. So close for the negative 3 over 5. Another close for the 2 inverse of cosine of negative 3 over 5, and another parenthesis because there is another function here. So press equal sign, it's negative 24 over 25. Okay, so that's all for today. I hope you enjoy learning about sample problems involving inverse trigonometric functions. And before I end up my video, I would like to give my special thanks to Mr. Eldren Dalican, and I hope you learned something. Goodbye!